ever pondered about the possibility of life beyond the confines of our planet Earth? If so, you're not alone. For centuries, mankind has been captivated by the enigma of extraterrestrial existence. We've sent spacecrafts to the furthest reaches of our solar system, probed the farthest corners of the cosmos, and peered into the deepest abyss of the universe. All in the quest for that elusive confirmation: we're not alone. In this vast expanse of cosmic wilderness, there's one place that has sparked our curiosity more than most. A place that's as enchanting as it is enigmatic. A place that's not just a moon, but a world in its own right. A place that's shrouded in mystery, yet holds the promise of something truly extraordinary. It's the second largest moon in our solar system, and it orbits the ringed giant, Saturn. As we delve into the mysteries of the universe, one celestial body captures our attention like no other: Titan. The year was 1655. Dutch astronomer Christian Huygens stared into the night sky and made a mind-blowing discovery. In the heart of the 17th century, the world was a place of scientific renaissance. The age of discovery had opened up new frontiers on Earth, but some daring minds were already gazing upwards, towards the heavens. One of these was Christian Huygens, a Dutch astronomer, mathematician, and all-around genius. Huygens was the man of the hour, having invented a new type of telescope, boasting a longer focal length than anything seen before. This incredible device, armed with a lens diameter of 2 inches and a focal length of 12 feet, was his key to the cosmos. One night, as Huygens peered through his telescope, his gaze fell upon the ringed planet, Saturn. But what caught his attention wasn't the planet itself, but one of its moons, a moon that would later be known as Titan. In Huygens' observations, Titan was a mere point of light, yet he could discern its orbital path around Saturn. He noted that it took 16 days and an odd number of hours for Titan to complete one orbit. This was no small feat for a 17th century astronomer. The discovery of Titan was groundbreaking, as it was only the 6th moon known to humans at the time, after our moon and the 4 Galilean moons of Jupiter. For Huygens, it was a testament to the power of his new telescope and his own observational skills. But for the world, it was the unveiling of a new celestial body, a new point of light to ponder and explore. Huygens would later go on to suggest that Saturn was surrounded by a ring, debunking earlier theories of it being a planet with large moons. His observations and theories laid the foundation for understanding the Saturnian system, and Titan in particular. Thus, Titan, Saturn's largest moon, entered our cosmic map, sparking centuries of curiosity and exploration. Fast forward to the 21st century, our understanding of Titan has come a long way from its initial discovery. Our journey to the mysterious moon of Saturn began with the Pioneer 11 spacecraft in 1979. This brave robotic explorer gave us our first up-close glimpse of Titan, revealing a dense, opaque atmosphere that hinted at the potential for complex chemistry. Then, in 1980 and 1981, the Voyager 1 and 2 spacecraft flew by. Voyager 1's instruments pierced Titan's smoggy veil and discovered that its atmosphere was primarily composed of nitrogen, with traces of methane and other hydrocarbons. This discovery was significant because it suggested that Titan's environment might be conducive to the formation of complex organic molecules, the building blocks of life. But it was the Cassini-Huygens mission, launched in 1997, that truly revolutionized our understanding of this intriguing moon. Cassini spent 13 years studying the Saturn system, and its Huygens probe made an historic landing on Titan in 2005. This was the first landing ever accomplished in the outer solar system, a monumental achievement. Huygens sent back stunning images of a landscape eerily similar to Earth, with river channels, lakes and seas, but composed of liquid methane and ethane rather than water. It discovered that Titan's surface temperature is a bone-chilling minus 290 degrees Fahrenheit, significantly colder than any place on Earth. Cassini's radar and infrared instruments revealed more about Titan's complex weather systems. They found that Titan experiences seasons, just like Earth, and has a methane cycle analogous to Earth's water cycle, with methane rain falling from the sky, filling lakes and seas, and evaporating back into the atmosphere. What's more, Cassini detected a vast underground ocean of water and ammonia, raising tantalizing questions about the potential for life beneath Titan's icy crust. The mission also found intriguing hints of active geology, including potential cryovolcanoes that could spew water and other materials from Titan's interior onto its surface. This discovery suggests that Titan is a dynamic world, not a frozen relic of the past. As we continue to analyze the wealth of data returned by Cassini, we're learning more and more about this fascinating moon. We've discovered that Titan's dunes are made of tiny particles of organic material, and that its lakes and seas are filled with complex hydrocarbons. We've found that its atmosphere is rich in complex organic molecules, and that its surface is constantly reshaped by wind and rain. Titan, it appears, is more akin to Earth than any other body in our solar system, yet it remains an alien world. Despite the similarities, Titan is a world of extremes, where the familiar meets the utterly alien, where rivers of methane carve valleys into an icy surface, and where a dense atmosphere shrouds a potentially active world. It's a place that both challenges our understanding of what's possible and tantalizes us with the potential for discovery. The similarities between Earth and Titan have led to a tantalizing question: could life exist on this distant moon? As we delve deeper into the mysteries of Titan, we're faced with some intriguing possibilities. Unlike other celestial bodies in our solar system, Titan's atmospheric composition and the presence of organic compounds have prompted discussions about the potential for life. But it's not life as we know it. Instead, we're talking about the concept of non-water-based life, a form of existence that might seem alien to us. Let's start with the basics. On Earth, life as we know it is carbon-based and relies heavily on water. But Titan is a freezing world, with temperatures plummeting to minus 290 degrees Fahrenheit, making it far too cold for liquid water to exist. Instead, Titan's lakes and rivers are filled with liquid methane and ethane, substances that are gases on Earth but exist in liquid form on Titan due to the frigid temperatures. This has led scientists to hypothesize about the possibility of a completely different kind of life, one that is based on methane rather than water. It's a radical idea, but not entirely without basis. Methane, like water, is a polar molecule, which means it can dissolve a wide range of substances and facilitate the kind of complex chemical reactions necessary for life. In addition to this, Titan's atmosphere is thick with organic compounds, the building blocks of life. These compounds, known as tholins, rain down from the atmosphere and cover the moon's surface with a rich organic sludge. Could these tholins, when mixed with liquid methane, give rise to some form of life? Moreover, there's another intriguing possibility: a subsurface ocean. Beneath Titan's icy surface, there could be a vast ocean of water and ammonia. This ocean, kept warm by tidal heating from Saturn's gravitational pull, could potentially harbor life. However, any organisms living there would need to endure extreme conditions, including high pressures and low temperatures. Despite these possibilities, it's important to remember that these are just theories. We haven't found any evidence of life on Titan yet. However, these hypotheses highlight how our understanding of life is evolving. We're beginning to realize that life might not be limited to the narrow conditions we find on Earth. It might be far more adaptable, resilient, and diverse than we ever imagined. While the conditions on Titan are harsh by Earth standards, life, as we are coming to understand, can be remarkably tenacious. Now, as we stand on the precipice of the future, another question arises: could we one day colonize Titan? Titan, Saturn's largest moon, presents both enormous challenges and opportunities for human colonization. Its harsh, cold environment, with temperatures plunging to a chilling minus 290 degrees Fahrenheit, and its lack of breathable air, make it a daunting prospect for human habitation. But if we can overcome these hurdles, what might the colonization of Titan look like? Firstly, let's consider the resources Titan could potentially offer. Titan's atmosphere is rich in nitrogen, a crucial component in the creation of breathable air. Moreover, it has abundant supplies of hydrocarbons in the form of methane and ethane lakes and rivers, which could potentially be used as a source of energy. These lakes and rivers, in fact, make Titan the only other place in our solar system, other than Earth, where stable bodies of surface liquid have been found. But to utilize these resources, we would need significant technological advancements. We would need to develop habitats that can withstand Titan's extreme cold and provide breathable air. We would also need to create technology that can convert Titan's hydrocarbons into a usable form of energy. The good news is, scientists and engineers are already working on these challenges. NASA, for instance, is currently developing a submarine that could explore Titan's methane and ethane seas, giving us valuable insights into how we might utilize these resources. Yet, colonizing Titan isn't just about overcoming technical challenges. There are also ethical considerations to take into account. For instance, if we find evidence of life on Titan, even if it's just microbial, do we have the right to colonize and potentially disrupt this alien ecosystem? We must tread carefully, balancing our desire to explore and colonize with our responsibility to protect and preserve. Titan's potential for colonization also raises questions about the future of humanity. If we can colonize Titan, what does this mean for us as a species? Could Titan be a stepping stone to colonizing other parts of the solar system or even other star systems? And what kind of society might we build on Titan? These are big questions. And while we don't have all the answers yet, we're beginning to explore the possibilities. In conclusion, while Titan presents considerable challenges for colonization, it also offers unique opportunities. Its abundant resources and unique environment could make it an ideal place for human habitation, provided we can overcome the technical hurdles and navigate the ethical considerations. Colonizing Titan, once the stuff of science fiction, is now a subject of serious scientific discussion. As we continue to explore the cosmos, Titan stands as a testament to the infinite possibilities that lie beyond our home planet. In the vast expanse of the universe, we're constantly reminded of the unknown. And Titan, the largest moon of Saturn, is a compelling embodiment of these unknowns. It's a world that has surprised us at every turn, from its discovery in the 17th century to the astonishing details we've uncovered in recent years. Let's take a moment to reflect on the journey we've embarked on so far. We've delved into the history of Titan's discovery, traced back to the early observations of Christian Huygens. We've explored the wealth of knowledge we've accumulated about this fascinating moon, from its dense atmosphere to its methane lakes and rivers. We've sifted through various theories about the possibility of life on Titan, a concept that, while still speculative, could redefine our understanding of life itself. But it's not just about understanding Titan, it's about envisioning what could be. We've also considered the tantalizing prospect of colonizing Titan. It's a notion that might seem far-fetched now, but as we've seen before, so were many of the ideas that have since become reality. With advancements in technology, with the collective will and curiosity of humanity, who knows what the future holds? And yet we're only at the beginning. There's still so much we don't know about Titan. Its unique environment presents a wealth of opportunities for scientific discovery and exploration. The potential for life, the possibility of colonization, these aren't just idle speculations. They're stepping stones to a future where we might not just be inhabitants of Earth, but citizens of the cosmos. The ongoing research and exploration of Titan are crucial in this regard. Every mission, every observation, every theory brings us one step closer to understanding this enigmatic moon and its potential. It's a testament to our enduring quest for knowledge, our relentless pursuit of the unknown. And while we're focused on Titan, let's not forget the bigger picture. Titan is but one of countless celestial bodies in our universe, each with their own mysteries to unravel, their own stories to tell. The exploration of Titan is part of a larger narrative, a grand adventure that spans the cosmos. It's a journey that continually challenges us, that pushes us to expand our horizons, to venture beyond what we know. So, as we gaze upon the stars, remember, the universe is full of mysteries waiting to be unraveled, and Titan is just one of them.